Right, good morning, welcome everyone, welcome in the room and welcome to our viewers online to today's CReDo conference. We've got a really exciting agenda today, which we'll go through. As we go through the agenda, what we'll be doing is taking all questions from the audience and from yourselves in the room via Slido, if I can click my screen to the right one. So if you have any questions just with the Gemini call, please do open up your phones, scan the QR code on screen, or go to slido.com and type in the code CReDo23. So my name is Simon Evans, and I'm the Global Digital Energy Leader at Arup. I'm also the chair of the Gemini call, which some of you might recognize. And today we have a very exciting agenda of a number of speakers from across the CReDo program sharing about the various developments and activities that are happening. So as I say, those joining us online, please do take part actively. Make sure you use the Slido to capture and put any comments or questions you have for our speakers. And of course, if you have any favorite questions, you can always like them, and we'll ask those questions as we go through the panel sessions in order of their priority. So before we start going through the agenda, I wanted to say a few things really. For me, whenever I talk about digital twins, I always typically start with an image of Henry Ford. You might have seen this one where a horse is pulling a car, and the quote that goes alongside it says, "If I'd asked people what they wanted, they'd have said faster horses." Now, many people, Steve Jobs and others, have said similar comments about other technology innovations. And of course, in that discussion there, Henry Ford is talking about the transition to the car from the horse. But what he's really talking about is education, and that until you can show people the art of the possible, it's really hard to understand and really get what they mean. And that's why it's on us as industry in the room and those joining online to really show, not just tell people, why digital twins are important. And we need to do so through tangible demonstrators, such as the CReDo program. Right, so with that, I'm going to hand over to Sarah and Lauren from the CReDo program, who are going to talk through the first item about CReDo and its phase 2 journey. But before they come to stage, I'd like to show you first a quick video about CReDo.
Extreme weather events caused by climate change are on the rise. When we're not prepared for these events, the consequences are more serious. Failures occur across interconnected infrastructure networks, meaning power cuts, loss of communication services, and running water. This can severely impact people's everyday lives. And this is only going to become more of a problem in the future as these events become more common and more extreme. Ensuring that infrastructure is resilient to these events is critical.
The climate change resilience of infrastructure networks is a challenge that is not yet well understood and is one we need to address urgently. Asset owners really need to know who are they dependent on. It's really crucial both for the integrity of the assets, but also for the service you provide your customers. For example, a range of infrastructure providers, if one of them is affected, let's say by flooding, and that maybe affects an electricity substation, and then that problem cascades to perhaps the water company that's using that electricity to run its plant and pump water, or perhaps the communications infrastructure that needs that electricity to run the communications network. Understanding these risks in advance and how we can mitigate them is key.
CReDo is really useful for angling water to increase our understanding of infrastructure, interdependencies, and the future climatic impacts on our infrastructure. If you think about what's at the core of CReDo, and that's data. In reality, it's how we are sharing and using data with BT and UK power networks, and then actually integrating future climatic models and scenarios. So once you've got that data in a connected digital twin that CReDo provides, it means that then we can start to visualize this data and use asset failure models to look at how assets become impacted and how quickly and over what sort of time period. This is really about planning for the future. So if we can really understand how our infrastructure is going to be impacted in 10, 20, 30 years' time, that means that the investments that we make and our partners make are in the right areas to protect our assets and ensure that we continue to provide that service to our customers.
This will allow asset owners to use CReDo to see the effect of extreme weather events on the combined infrastructure network. And crucially, this will inform what interventions they can make to increase the system resilience.
CReDo allows BT to share information with other critical national infrastructure providers in a safe and secure way. It's a distributed architecture where we retain control over our data assets, but allow us to share those data aspects which enable others to better understand dependencies between different infrastructure.
CReDo has been designed so that it can be extensible to other asset owners, new sectors, wider geographical regions, and a range of extreme weather events. The wider benefits are actually, it improves overall resilience. The more participants there are, the more holistic the solution that we see, and a better understanding of that interaction between those wider network groups, increasing the benefits from using CReDo.
Collaboration through connected digital twins is key to tackling climate change. Can you work with us to expand our network? To get involved, visit the Digital Twin Hub CReDo Taking Action page.
We are delighted to have you with us here today in person and online. So thank you very much for joining us. The film gives us a flavour of what CReDo is all about. And today we want to delve into CReDo in more detail and share with you what we've been doing over the past year, and to give you a sense of where we're at on the CReDo journey. So I think that journey started back in 2017 with the publication of the report, Data for the Public Good. And this report, published by the National Infrastructure Commission, recommended that there needs to be a pilot project, a demonstrator project, to show that there are benefits from sharing data across infrastructure sectors. And so CReDo was launched back in March 2021 under the Centre for Digital Built Britain and the Digital Twin Hub. And from March 22 onwards, CReDo has been taken forward by Connected Places Catapult under what we call phase 2. And that's what we're talking about today. And we hope that CReDo will be taken forward in the future through further innovation funding. So we're talking about digital twins today. So what do we mean by digital twins? What do we mean by a digital twin? We find it helps to take a fairly broad church approach to describing digital twins. And I would say that a digital twin is a digital representation of something physical. And that something physical could be in the past, the present, or the future. But there's some kind of data relation between the physical world and the digital world. And we can use that data in the digital world to help us make a decision that then impacts upon the physical world. So when you're developing a digital twin, it's helpful to think about, what are you developing it for? What's its purpose? What's its use case? And in the case of CReDo, it's about climate resilience. So it's using a digital twin to understand the impact of extreme weather events across the infrastructure system. And you want to think about, who are the stakeholders? So who's using the digital twin? In the case of CReDo, it's the asset owners using CReDo to help them make decisions. And then who's impacted by the digital twin? And that's you and me, people who live in areas that will be impacted by extreme weather events in the future. And of course, you don't want to just think about your digital twin in isolation to other digital twins, a water sector digital twin or an energy network digital twin. You want to think about how your digital twin can connect up with other digital twins so that we can share data across organizations and across sectors, so that we're all part of an ecosystem of connected digital twins. And CReDo is a climate change adaptation digital twin. It brings together data across energy, water, and telecoms networks. We're working with Anglian Water, with BT and Openreach, and with UK Power Networks, who bring their people and their data to this project. And just by bringing this data together in one place, the data about the assets, we can start to spot the interdependencies across the infrastructure system. And in CReDo, we're looking at the impacts of future storms caused by climate change across the infrastructure system. In particular, we're looking at the impact of flooding. So we have flood data in the model so that we can see what the impact of future storm events would be across the infrastructure system. And the CReDo digital twin looks at the probabilities of assets failing when they are wet. And then it takes those wet failed assets and it propagates the failure across the whole system. So you can see, as a result of a storm in the future, which assets would be out of service. And it also looks at assets that would be in areas that are dry. So you would see assets in dry areas that are out of service because they are dependent on wet failed assets. So you're starting to see that whole impact across the infrastructure system and the cascade of failure. So it's really helping us to think about these questions of how do we prepare for these events and how do we respond in the future. So helping us think about these big questions around system resilience and adaptation. And the vision for CReDo is that asset owners will be using CReDo as a connected digital twin in the future to help make decisions where they're able to assess what the impact of different interventions is across the infrastructure system. So, for example, looking at the impact of relocating a power substation outside of a flood zone and being able to assess in a storm scenario what the impact would be on resilience and people being able to have access to running water, to power, to communications. And it's really helping us to look at system resilience rather than individual network resilience. So that's the vision that we're working towards, is this tool being usable across asset owners. In phase 1 of CReDo, we were under a lot of time pressure. So the approach that we took was to use a centralized data sharing architecture. So we put all the asset data into one central pot. But the problem that we found with that is that according to the conditions of the data license, where we had to treat the data very carefully, we weren't then able to share the insights back with the asset owners, because within the time constraints of phase 1, we weren't able to develop the authentication processes for the asset owners to be able to view those insights. So that's something that we've been working on in phase 2, and Jethro will be talking about that in more detail. And the other problem that we found in phase 1 is that there are limits to scalability. So over time, we want to add in other asset owners, other sectors, and looking at other types of extreme weather events, or other types of climate data. And the problem that we find with a central database approach is that it won't scale over time. So what we've been exploring in phase 2 is a distributed architecture where the asset owners can retain control over their data. And ultimately, we'll be able to add in other asset owners, other sectors, and other types of climate data. And Jethro will be talking more about that later on and giving you the lowdown of what we've been doing there. And we see that all of us here today are on a journey towards connected digital twins. And we see that that future looks like a future where we've got an ecosystem distributed architecture where we're able to share data across sectors, across organizations. And we hope that you'll feel part of that journey today in hearing about what we're doing on CReDo. So I'm going to hand over to Lauren now, who's going to talk about the focus for phase 2.
Lovely. Thank you, Sarah. As Sarah's just explained, we're aiming for a future where CReDo could just be one of many connected digital twins in an ecosystem helping to tackle climate change use cases. So how are we doing this in CReDo's phase 2? to enable those objectives? Well, our mission statement is to build upon the work that was done by the consortium led by the Centre for Digital Built Britain as part of the National Digital Twin Programme, and take their system from a proof of concept and build it up to a working prototype where asset owners can get their first systems view of the cross-sector network using real asset data. And where CReDo can then be ready to expand to new asset owners and wider geographies, enabling network effect benefits to be realized where more participants come into the system. And we're doing this by these 5 objectives shown on the screen. So firstly, we're moving to a distributed architecture that helps build trust and allows asset owners to retain control of their data in their own environments. 2, we're sharing system level viewpoints with asset owners on a need to know basis so that what they see in the system is controlled by the conditions of their mutually agreed data sharing agreements. 3, we're using flexible and extensible system design to enable us to easily expand to new asset owners and new data types. 4, we're promoting interoperability with continued collaboration with other digital twin projects and new emerging data ontologies. 5, probably the most important, is we are unlocking the strategic planning use case so that asset owners have insights available to them to make smarter investment decisions where the overall system climate change resilience will benefit the most. Collaboration through connected digital twins is key to tackling climate change. And the project's been really lucky to partner and work with some amazing organizations on this challenge. The team that we work with is comprised of people from a diverse and hugely varied mix of skills and specialisms. Connected Places Catapult has been involved from the start, but the project's future and its continuity is dependent on all of these partners showed on the screen. CReDo's success is their success as much as anyone else's. I do want to do a few thanks. So we're particularly grateful to the asset owners, to Anglian Water, UK Power Networks, BT and Openreach. They are the beating heart of the CReDo project, and their innovative and intrepid approach to sharing their asset data is what makes this project work. I'd also like to give special thanks to CMCL. Their work developing the technology and overcoming head-scratching problems about how to get distributed pieces of data talking to each other has been key. Also, the Science and Technology Facilities Council, their work on data hosting and emulating of distributed hosting architectures and the diligence in maintaining cybersecurity protocols has been essential. And lastly, to Frontier Economics for spearheading the analysis into the economic benefits of CReDo, which is key to us building a value proposition for wider use of connected digital twins in the future. There are so many others shown on this slide that I'd like to thank personally, but unfortunately just isn't time. So I will just say thank you to everyone else that's made CReDo Phase 2 a reality. We couldn't have done it without you. Thank you very much. I'll now hand back to Simon to introduce the next speakers.
Brilliant. So some great content and frame setting already. We're going to go into our next speakers, where we have Sarah from Frontier Economics and Elliot, technical lead from CReDo, going to be talking in a second. But before we do so, I want to encourage you that if you have any questions for our speakers at all, please do post them into Slido. Go to slido.com and type in the code Gemini23, or follow the code that was on screen before. So can I welcome please Elliot and Sarah?
Thanks, Simon, and hi, everyone. Today, Sarah and I are going to be sharing with you the work that we've been doing on developing economic models and decision support methods that we're working on to help decision makers and network operators in planning for more resilient connected infrastructure, and how this will benefit network operators, customers, and wider society. As we've been hearing, We know that the everyday running of infrastructure connects across sectors and organizational boundaries. Power services provide energy and power to the water network and the communications network, and it provides the energy and electricity to heat our homes. Communications are needed for the operation of the water and power services, and internet is crucial to our everyday business as usual. Finally, the water network is needed to maintain drainage systems, to keep all of our assets dry, and to provide clean water for us to drink. And these complex connections and interdependencies connect deep into society and other services, including things like transport, healthcare, and other emergency services. But as we know, the pressures on infrastructure are increasing due to the effects of climate change, which are expected to make extreme weather events more often and more severe. And we really need to understand how these interdependencies work and the effects of extreme weather that will happen to our infrastructure. But we can't plan for a more resilient future in silos. It simply won't work because of these network effects. What we need to future-proof our system, our critical infrastructure, is a whole system approach. And this is where CReDo comes in. As you've seen, and as you've seen from the video, and as you've heard, what we've done with CReDo is we're developing a system of models that allows us to connect data and understand the vulnerabilities across this whole system of interconnected networks, and doing this from this systems perspective. But once you have this understanding of how failures cascade through the system, what you end up with from looking at lots of different climate scenarios is a lot of data, and it's hard to make decisions from these. So what we really need to do is go beyond and aggregate this data and understand how we can combine this together using decision algorithms and economic models to convert this data into actionable insights. And this is what we've been doing with developing these algorithms in helping to help planners plan for more resilient infrastructure, to make coordinated interventions and cross-sector investment into this resilience. And by doing this, we'll make our infrastructure more resilient so that we can keep the lights on at a lower cost to the network operators and to society. So what I want to do first is talk you through a kind of cartoon of how this decision support might work. So let's start with this very simple scenario where we are just looking at the connections of the network. So here we have the power assets in this orange and yellow. We've got the communications assets in purple, and we've got the water assets in blue. And what we want to do with this is we've connected it up with these directed arrows that show how the connections go from one side to the other. And at the moment, they're green, which is representing all the connections are currently working and all the services are being provided between different assets. But then what we could do is think about what happens if we introduce this flood. This is a sort of moderate flood, a 1 in 10-year event, let's say. And what you see is that when this comes in, it causes the site, the first site on the left here, the power site, to fail, perhaps due to flooding, and this failure then cascades through the network, represented by these red directed arrows now. And the effects of losing this power will cascade into the other systems. The communication systems might now not have power to run, and neither will the water. Of course, what we might do as individual network operators is look at our own networks, and we want to plan it against this flooding event and against floods. But if we're working in a siloed way, then all we can do is look at our own networks and understand what the the best interventions that we can make to protect our own infrastructure. And so you might expect that each of the network operators are investing in flood defenses represented by these dashed lines around their assets. But what you can see in this scenario is that because of the localized flood, it's really the power asset that's the one that needs the most protection. In this moderate flood event, we might expect that the flooding investment is sufficient for this case. But now let's consider a more severe flooding event that, as I've said, is going to become more likely in the future. In this event, the budget constraints might lead to a flood defense that from the power network on its own isn't sufficient to protect its site. But really this effect now of cascades through the network. Instead, what we're proposing is a method for cross-sector investment and a way of using CReDo to look at the whole network and understand where the best interventions are for collaborative decision-making and coordination that will lead to a more protected network. And in this case, this is the network operators can combine together. They can choose to invest in the most critical parts of the system. They're doing this now at a combined lower cost to the overall set of network operators, and they're increasing the resilience at the same time. Now, of course, this is a simple cartoon picture, but it gets across the message that you might be able to look at a complex network, understand the different network effects, explore a whole range of different scenarios, and determine from an economic perspective what the best investments are to make. And with that, I'm going to hand over to Sarah, who's now going to talk through in a bit more detail some of the details of this.
Thank you, Elliot. So I'm going to talk through how CReDo works as a decision-making support tool for asset operators. There are 5 components within the CReDo model. I'll talk about each component in more detail in what follows, but before I do, I just want to characterize the components at a high level to help you understand how they all fit together. So component 1 characterizes the assets in the network, the interdependencies of those assets, and captures the existing level of resilience of those assets. Component 2 simulates, as Elliot's shown, the impact of a weather event on networks on assets within the network. It shows what assets fail, and it then calculates the economic impact of those failures on stakeholders. Components 1 and 2 focus on understanding the impact of a weather event on the assets in the network and the consequent impact on stakeholders in what we call a do-nothing scenario, i.e. where asset operators make no additional mitigation investments relative to the situation today. Component 3, on the other hand, is a key step in understanding what investments could be made by assets and where they should be made in the system. It does so by assessing the economic cost of asset failures for a given flooding event, what we call asset criticality, and ranking assets according to their criticality. This identifies those assets that impose most costs on the system if they fail. Component 4 then simulates the impact of a range of alternative interventions on resilience that could be made and compares the impact of those interventions on economic costs relative to the do-nothing situation. Component 5 then brings those together to understand the expected net present value of those interventions so that you can compare different alternatives as a decision maker. It also enables us to understand the added value that CReDo offers as a tool relative to both the do-nothing scenario and also a version of siloed digital twins. So step 1 in a little bit more detail. So what we have in component 1 is we characterize the assets in a network, as Elliot's already sort of outlined in the cartoon version, and we look at the interdependencies between those assets and the existing resilience levels of those assets. We do this by drawing together real asset data from across the different network operators, and we also include real data on the resilience properties of those assets. And in so doing, we capture both preventative measures, preventative resilience measures. So those are measures which prevent floodwater from reaching critical equipment, and also containment measures, those which act to contain the impact of faults on affected assets and mitigate the impact of a fault from the cascade effects that follow. This slide traces the theoretical journey of an extreme weather event in terms of the CReDo model, and the measures identified in red are the resilience interventions that we've considered as part of this process. Step 2 simulates the impact of weather events on the network and its stakeholders with today's mitigation actions in place. The diagram shows a chain of cause and effect. So it starts with a severe weather event. Then we have preventative measures in place which determine what the state of the assets are in terms of failure. We then subsequently take into account containment measures, and then that flows through into outcomes for stakeholders. And in terms of considering outcomes for stakeholders, we consider that from a variety of different perspectives. So firstly, the customer impacts, so the resulting impacts on consumers that result from a discontinuity of service from their asset provider. We also think about wider stakeholders, so that could be things like the impact of pollution from an event, and also we consider the economic impact for asset operators themselves. So that includes obviously investment and cost incurred in order to repair or restate the assets, as well as potential financial measures that aim, so things like penalties that aim to reflect the economic costs to consumers and wider stakeholders in the system. Component 3, so up until now, components 1 and 2 have indicated the effect of a flooding event in terms of stakeholder outcomes, assuming that asset operator investment in mitigation is fixed, so the do-nothing scenario. CReDo, as a decision-making support tool, can be used to assess the overall benefits associated with additional flooding mitigation interventions, and component 3 helps us to do that. It considers where investment is most critical in the system by estimating the economic costs associated with flooding events for every asset in the system. And criticality is assessed according to the economic cost of the failure of a given asset would impose on the system over a period up to 2050. The diagram on this slide sort of mirrors Elliot's cartoon version and shows that in this situation, the electricity asset shown with the red high criticality band would be considered to be critical to the system and therefore priority for investment. Component 4 then considers a set of resilience interventions that can be put in place to improve the resilience of the most critical assets in the system. For each intervention, CReDo estimates the economic impact of the intervention on outcomes and compares it to the do-nothing scenario. It enables a return on investment calculation to be made, considering both the upfront cost of making the intervention and also the economic benefit associated with the flooding mitigation that it brings about. And we then compare that to the do-nothing scenario. CReDo ranks the interventions according to their expected net present value, and that can be used to support decision makers in comparing alternative intervention scenarios from a system perspective. And it considers the overall economic benefit associated with different options, not just the benefit that accrues to individual asset operators. Finally then, step 5, I mean, up until now I've described CReDo as a decision support making tool. The final component here enables us to estimate the overall economic value associated with joined up resilience planning versus either a do-nothing scenario or what we call a silo digital twin. So that's where asset operators are making investments using a digital twin, but doing that independent of each other. So it enables us to consider both how CReDo adds economic value over and above the do nothing scenario, and also the siloed digital twin. So what is the incremental value add of CReDo over and above that comes from connecting digital twins together? It does that by enabling us to compare the overall economic outcomes that result under the CReDo scenario with the economic outcomes that would result from a do nothing intervention and also a siloed digital twin intervention. It enables us to compare both the level of resilience associated with each of these scenarios, as shown on this slide, as well as the economic value associated with the resulting resilience outcomes, which hopefully we'll see on the next slide. This slide illustrates how CReDo can be used to estimate the economic costs of flooding events and the cost of flooding mitigation activities in each of the scenarios. The blue wavy line here shows the economic costs associated with flooding events and illustrates that these costs are lower in the siloed scenario compared to the do nothing scenario. So we go from, I think, roughly about 12 wavy lines down to close to 3 in the siloed digital twin intervention. And as you'll see, obviously that comes with an increased cost from taking additional resilience activities. So we can look at comparing those two separately. It enables us to compare that to a CReDo intervention, which is the connected digital twins working together. And again, you can see here, the simulation would show that the wavy lines, so the cost of flooding has reduced down to just over 1.5 lines. And again, that the CReDo, the result of joining up across the different connected twins not only has enabled the cost of flooding to be reduced, but also the cost of increasing that resilience activity to be reduced across the system. At the moment, we're in the middle of estimating these benefits with the real CReDo data, and we will be publishing a phase 2 report at the end of March. So at the moment, I can't put real numbers to these things, but do keep an eye out for the report, which we'll be following in a few weeks' time. Before I finish up, very conscious that over the last few months, our work has very much been focused on developing CReDo as a decision-making support tool for asset operators. But we're aware that CReDo has a variety of wider benefits that go beyond that. And I wanted to highlight some of those now. So as a demonstrator project, CReDo is expected to bring about a range of benefits for asset operators, their customers, and wider society beyond those we've articulated in the slide. So to provide an example, this includes more efficient and effective ways to share information across asset operators, ways to assist decision-making and drive insights from data. There could also be wider spillover benefits, for example, by progressing the discussion on climate change and also improving the quality and the availability of data. Thanks.
Brilliant, thank you, Sarah. Really interesting to hear about how we might look at the benefits case for it as well. So watch out for that report at the end of March. Before I introduce Jethro, I want to again encourage you that whilst you are in the room here, we also have hundreds of people joining us online. So thank you for partaking in this session. Questions are all being asked via Slido, and we will ask those to our speakers on the panel towards the end of this agenda. Please do post your questions into Slido. We've had about 45 so far, but also go in and like or thumbs up various questions, and we will ask them in the priority of which they're most liked. So please go on, have a quick flick through and see which questions you want our speakers to address first. So I'd like to introduce Jethro next from CMCL to give a presentation on the technical update. Jethro.
Thank you, Simon. Hi, everyone. I'm Jethro. I led the team from CMCL that implemented many of the technical aspects of CReDo. And today, I'd like to explain to you what data structure we used and why we chose it, why we believe that CReDo requires a distributed architecture, and the technical solution that we adopted, and how it supports the needs of CReDo. Finally, I will finish with a live demonstration of the CReDo visualization. So in CReDo phase 1, we demonstrated how to share data describing infrastructure from the water, energy, and telecoms networks, and how to combine this with flood data to simulate the resulting cascade of failures across the overall infrastructure network. Behind the scenes, CReDo represented the assets and their connectivity as a knowledge graph and used computational agents acting on the knowledge graph to simulate the behavior of assets. The starting point to build the knowledge graph is to define ontologies. And you can think of these as the internal data structure of CReDo. I'm going to start by introducing the ontologies and explain how we use them to create the knowledge graph. The ontologies that CReDo uses are hierarchical. At the top of the hierarchy, we define concepts and relationships about assets and flood data that apply throughout CReDo. We then define specializations of these concepts for each of the water, telecoms, and energy networks. The ability to define these specializations confers extensibility because it makes it easy to add new specializations for new types of asset. This slide illustrates some of the main concepts and relationships that apply throughout CReDo. The concepts are the nodes in the graph, and the relationships are the arrows on the diagram. So, for example, an asset will have an owner and a set of properties describing the flood, the operational state of the asset, and its location, and so on. Crucially, an asset may also supply something, for example, power, to another asset. And this is represented by the green curly arrow on the diagram. We now define specializations of these concepts and relations for each individual network. So for the water network, we define specializations of the assets that you see on the left in the blue box. We define specializations of the supplies relationship represented by the blue arrows. And we define specializations of the asset properties that you see on the right that are relevant to the water network. We do the same thing for the telecoms network. We define specializations of the assets in the colored box, a specialization of the supplies relationship represented by the purple arrow, and specializations of the asset states. And likewise, for the power network, we define specializations of the assets, again in the colored box, specializations of the supplies relationship represented by the colored arrow, and specializations of the state of the assets relevant to the power network. We then use these ontologies, and when we do that, when we use the ontologies to represent data, we form a directed graph. The instances of the concepts, in this case the assets, form the nodes of the graph, while the relationships between concepts, in this case the supplies relationships, form the arrows between nodes. And instantiating the data in this way is the basis of how we form the CReDo knowledge graph. And the structure of the knowledge graph is significantly reflected in the appearance of the network on the CReDo visualization. in CReDo, we use computational agents, so computer models that operate on the knowledge graph to describe the response of each asset to flooding and to resolve the cascade of failures through the combined network. Our hierarchical use of ontologies confers advantages. The ability to introduce specializations of the concepts and the relationships makes it easy to extend CReDo. And by writing the computational agents in terms of the core concepts and relationships, we develop code that is able to interoperate across all of the specializations. In other words, we develop interoperability between the data from the different asset networks. In CReDo phase 1, we adopted a centralized architecture. Although we represented the data as a knowledge graph, we did so by taking a copy of the data and creating the knowledge graph in a centralized manner on a single computer facility. And the reason we did this was to keep everything as simple and as secure as possible. Workshops held with the asset owners at the end of CReDo phase 1 identified several open questions. How to scale and extend CReDo. How to enable data sharing and share insights back to asset owners whilst respecting the confidentiality of the underlying data. And this was something that we were not able to do because of the time available in phase 1. These two questions, the requirements posed by these questions, motivated the adoption and development of a distributed architecture in phase 2. The idea of the distributed architecture is to create a virtual knowledge graph that connects remotely hosted data. This includes the possibility of connecting to asset owner data at source. This would avoid the need to copy data, and avoiding this copying is an important component of making CReDo extensible. The proposed architecture also includes the possibility of mapping data from whatever format is used by asset owners into the CReDo data structure. This is important because it maximizes outward compatibility with other data models. It means that CReDo and other tools can use whatever internal data structures suit their purposes while using mappings to access data in its native format. This includes the possibility of different asset owners having different data formats. And this is particularly important because I think we all recognize that digitalization is a journey and that different parties are in different places on that journey. Once the data is mapped into the CReDo data structure, we achieve the same benefits in terms of creating interoperability that we demonstrated in CReDo phase 1. The distributed architecture makes provision for security, access, and quality protocols to protect asset owner data. And this is represented by the padlocks on the figure. The possibility to connect to asset owner data at source means that asset owners could retain control of their data assets within their own IT systems and, subject to some suitable agreement, would allow CReDo to access data and would allow CReDo to return insights, with the details of the agreement specifying how much detail about the overall network might be visible alongside those insights. In this manner, CReDo would be able to access data from multiple asset owners and process the shared data to generate insights into the overall connected infrastructure network. CReDo is designed to be extensible. Possible examples of this include the extension to other climate projection and weather hazard data, the extension to allow other users, perhaps regulators such as Ofgem, Ofwat, or Ofcom, to access insights, the extension to include other types of assets in the analyses, and last but not least, it includes the extension to allow other asset owners to play a role like Anglian Water, BT, and UK Power Networks. And as Barry Hatton said in the film, the more participants, the better our understanding of the interaction between networks and the impact of cascading risk. So I've made my case for why we're interested in a distributed architecture. The next question is, how do we actually do this? This diagram shows the solution that we've started developing. On the right-hand side, the asset owner data is hosted on separate servers. By separating the data, we aim to be secure by design, so avoiding the risks associated with hosting all of the data in the same place. Each server also runs a separate visualization, providing a means to facilitate different views of the insights and data. In the middle of the diagram is a central node, and in the current implementation, this is responsible for resolving the connectivity between assets, for simulating asset failures, and the cascade of effects across the combined network, and for managing scenarios. So, for example, which combinations of climate and asset data are analyzed. On the left-hand side of the diagram, we connect to data and service providers. For example, climate projection and flood data, which in phase 2 have been provided by Fathom. We also connect to other models, for example, to assess the economic consequences of a scenario and recommend possible actions to improve resilience. Finally, we also connect to other data sources. For example, data about NHS infrastructure. So the vision here is of an extensible system where multiple providers can offer models and data. This is facilitated and demonstrated by the idea of computational agents, each of which provide a discrete piece of functionality, as opposed to the idea of having a single bit of code that tries to do everything. In CReDo phase 2, we've done work to develop this architecture, but of course, there's always more that we'd like to do. Finally, I should also explain that the asset owner data was hosted by STFC in a secure environment within Daphne during phase 2. This included the use of separate virtual machines to play the role of each asset owner server. This allowed us to mimic the envisaged distributed setup whilst providing a safe environment while the project was in progress. So, just like in CReDo phase 1, we analyzed shared data to develop a connected understanding of the overall system. And in this sketch, we depict a flood that compromises 2 assets from the energy network, along with the effects on downstream assets from the other networks. The distributed architecture supports different views of the shared data. And here it is critical to distinguish the view. So the data that might be visible to someone and that they might be able to pull out of the system, we must distinguish this from the data sharing that has enabled the insights to be generated by analyzing the overall connected network. This slide shows the view that might be visible to Anglian Water. So, for example, it shows assets from their network, along with insights, in this case, the operational states of assets, derived from the analysis of the overall network using shared data. The insights include information about the state of each asset and about the state of incoming and outgoing connections, even where the connections go to and from other networks. The view that might be available to BT follows suit, as does the view that might be available to UKPN. But this is not the only possibility. In the event of suitable agreements, the distributed architecture allows connections to all of the visualizations, and by doing so, it is possible to retrieve the full system view of the overall connected infrastructure network. And we can go further. The system is extensible and can accommodate new asset owners and new types of assets. For example, data about critical NHS infrastructure. This system-wide view may be useful to asset owners and regulators alike, for example. So the remaining challenge is how to provide suitable security and access controls. This has been addressed by the Science and Technologies Facilities Council. The visualizations are able to be accessed via a CReDo webpage. The webpage requires multi-factor authentication, and once signed in, the user is then redirected to an appropriate visualization. So, for example, a user from UKPN would be redirected to the visualization on the UKPN server. The solution is based on the use of Keycloak, which provides an open source identity management platform. The solution performs authentication and authorization. So authentication is the act of confirming the identity of a user, Authorization is the act of controlling the permissions for who can access what. The solution is based on the use of open industry standard protocols, which confers a number of advantages. It allows the use of standard authentication apps, such as Microsoft or Google Authenticator. And in the future, it would allow CReDo access to CReDo via existing corporate logins. Overall, we see CReDo as part of a wider ecosystem of digital twins, interacting via a distributed architecture. Not the CReDo architecture, but some future ecosystem architecture that allows CReDo and other digital twins to operate on shared data, not just data from infrastructure, but data from across society. And by doing so, embracing a systems of systems approach to generating insights and facilitating interventions. So I would now like to turn to a live demonstration of CReDo. You will need to give me a couple of seconds to get this set up. The visualization has been developed to allow data and insights generated by CReDo to be interrogated. Today, I'm going to show you a scenario for a flood hazard with a 1 in 1,000 year return period under a high emissions scenario. So, the flood hazard data has been provided by Fathom and is provided as separate layers for different sub-perils, including coastal flooding, fluvial, so river, and pluvial, rain flooding. And this is the same underlying data set that has been the subject of a BBC News report about flood hazards this morning. The separation of the data into separate sub-perils enables the possibility of understanding the sensitivity of the combined infrastructure network to different types of flooding. The sensitivities will, of course, be time and place specific, and together with the type of flood, will have implications for the different types of damage and the different types of protection that may be required for different assets in different locations. So, for example, the protection required from saltwater flooding may be quite different from that required for freshwater flooding. And by comparing the vulnerability of different climate scenarios, by comparing the vulnerability of assets for different climate scenarios, we can understand the difference in implication for different timescales. So 2030, 2050, and 2070, for example. The data from Fathom has national coverage. And if I show the original area of interest for CReDo, the little gray bit in the center, you will gain an appreciation of the increase in geographic scale compared to CReDo phase 1. We're now going to zoom in on that area of interest. And I'm going to disable the gray bit so that it's easier to see. The visualization that I'm demonstrating today has permissions to see the full system view. Asset owners would be able to see real data covering the entire region, but this demonstration is going to use synthetic data that covers a smaller region. And the reason for this is, of course, to protect the confidentiality of the real asset data. I'm going to enable the view of the assets and the connectivity a little bit at a time. I've enabled the view of sewage sites, and I'm going to enable the view of the connectivity of the sewage network. So I appreciate it may take maybe a bit of an eye test, but in principle, what I hope you can see is that the sewage network pumps sewage from the town towards the sewage treatment facility on the edge of the river. I'm now going to enable primary substations from the power network. You can see 3 of them, one in the center of the screen, one to the right, and one closer to the top of the screen. And telephone exchanges from the telecoms network. I'm now going to enable secondary substations, telephone cabinets, and mobile phone masts. And the picture gets a bit busier. I'm going to finish it off by enabling the remaining connections between assets. A red border around an asset indicates something that has failed because it has flooded. So this might be an asset that requires someone to go to it and do something to fix it. An orange border indicates something that has failed because of a problem somewhere upstream. So for example, a secondary substation that is no longer receiving power. A gray border indicates something that is still working, but that has some other problem. For example, perhaps a substation that has lost telecoms or water. By viewing the data in this way, we can start to understand how the cascade of problems traverses the combined network. I'm going to pick out a few assets and talk you through some of what's happening. I'd like to draw your attention to the primary substation in the center of the screen. This asset has a red border. It has failed because it's flooded. And as a consequence of this, all of the connections emanating from it, all of the power connections emanating from it, have also been marked as having failed. Things connected to it, such, for example, this secondary substation, have also failed. This secondary substation is not itself flooded, but it's no longer receiving power and is therefore marked as having an indirect failure. The same is true of this sewage pumping station. This is potentially lucky because if this pumping station were able to keep pumping sewage, it would pump it to an asset that is actually also flooded. These indirect failures, we don't observe them up in the cluster of secondary substations up here. This is because these secondary substations have an alternative power supply route from a primary substation nearer the river. And although there is water in the vicinity of this primary power substation, the flooding in the vicinity is not severe enough to overwhelm the secondary substation. It's still functioning. But it is noted as having some other problem. it has lost telephone connectivity as a consequence of the telephone exchange that supplies it also having flooded. In addition to the map, there is also a dashboard. So this is the first iteration of an analytics dashboard. And whereas the map can only show one scenario at once, the dashboard allows information to be summarized across multiple scenarios. The idea is to provide a succinct summary of the information that's needed to support decision-making about interventions. So, for example, an overview of the assets with the highest probability of failure and the highest connectivity. In other words, measures of frequency and consequence. And to display this alongside outputs from the economic analysis of different options to increase resilience. And with all of these insights calculated on the basis of the full set of shared data and the cascade of failures across the combined network. Finally, I'd like to return to the map. And the eagle-eyed amongst you may have noticed that we have some healthcare system assets on the legend. I'm now going to enable the view of these assets. And I'd like to draw your attention to a couple of things. We have a hospital near the bottom of the screen. This has flooded. And in addition to having flooded, it has lost power and it has lost telephone service. There is a hospital at the top of the screen that is not itself flooded, but is suffering a similar loss of power and telephone connectivity. I beg your pardon. And there is a hospital on the left that has power, yet has lost telephone connectivity. This example is relevant because it speaks to the extensibility of CReDo, both in terms of new types of asset and new asset owners, and the ability to include these assets into the assessment of the cascading risk. I hope this has given you a flavor of what the project team has been able to achieve over the last few months and how cross-sector data sharing and connected digital twins might help us to understand infrastructure systems better and intervene more effectively. Thank you for listening. Simon.
Brilliant, thank you. So I'd like to invite up some of our asset owners, and we're also going to get our chairs rearranged in a second. So before the asset owners stand up, and we will be asking questions particular to the asset owners in this next section. If you have any questions at all, do post them into CReDo. But this first panel is focused on questions for our asset owners. We will have a second panel towards the end of the agenda where we'll be speaking to the CReDo team themselves. So asset owners, please, can I welcome you to the stage? And if you haven't got the CReDo link, you can scan it on stage here on the screen or go to CReDo.com and type in the code CReDo23. Asset owners and industry experts, of course. Any of you in the room as well, if you'd like to ask a question verbally, we do have some roaming mics, so we can pick up your verbal questions. But sorry, online, you have to ask your questions via CReDo. So I'm going to ask each of our audience, and hopefully the two that are joining us virtually in a second, to introduce themselves briefly and give a 1-minute reflection on just what they've heard. So I'm going to go in order of which you can see on the agenda here. So Alex, if I can start with yourself, please.
Okay, well, there's a lot to unpack, isn't there? So I'm Alex Winchester. I'm from Milestone Infrastructure. We are, I think, the largest highway maintenance service provider in the UK. So we're not necessarily an asset owner, but we are certainly maintaining assets for a wide variety of owners across the UK. So the highways are slightly outside the current scope of CReDo, but looking at what we heard today, I realized just there are really 4 points of key relevance that jumped out to me immediately. One is, with the climate change we are experiencing, I think the cycle of degradation to highways is going to change with extreme weather events. We all know that roads get worse in winter, but if we have more flooding, that's going to substantially change the investment we need to maintain our highways. But beyond that, I think it's also key that good maintenance and planning of highways is going to help that resilience, because the runoff from our highways in flood event scenarios is also very critical to the situations we've seen modeled. Third point is, of course, if we are undertaking any remedial measures to a flood event, you need good highways to get there. And I think the final point for me, and not many people may realize this, but the street lighting asset networks we have in the UK are effectively one of the best smart city assets we have. We can use an Internet of Things approach from individual street lighting lanterns if we need to monitor and track the progress of any of these events as they occur. So where does that take me in terms of what I saw today? I have to admit, I was hugely impressed. I came here with a much more cynical set of questions to raise. I was particularly delighted to understand the distributed architecture you're working on, because when I hear of connected digital twins, I always worry that we're going to spend more time focusing on interoperability of bespoke systems than getting access to the real data. What you're talking about here is getting access to the real data in a secure fashion. I think provides us the best opportunity to really begin to work on a large, distributed, but all-encompassing data set to model things accurately, because what we'll be working on is the master data that the asset owners themselves maintain. Every step you take away from that master data that is maintained, I think increases your risk of inaccuracy. So for me, that was hugely positive, and I was delighted to hear that this morning.
Great, thank you very much, Alex. Nigel, can I ask you to give an introduction and 1 minute, please?
Of course, yeah. So Nigel Watson, CIO, Northumbrian Water Group. We are asset owners, 50-odd thousand kilometres of pipe and several hundred treatment works. I'm very impressed by what I've seen today. I say that first off. I think absolutely convinced that it aligns with need in the sense that we are facing into climate change, seeing the impact of that every day. And energy and water in particular, I can see definitely need to work more closely together. So we are looking at one of our main responses to, if you like, water shortage is potentially desalination, incredibly energy intensive. Somewhat ironically, energy is looking at hydrogen as a means of storage, incredibly water intensive, right? So I think it's very clear that we have to join up decision making. And so I think initiatives like this are quite key. I'm a massive fan of digital twins, have been for several years. We've got many of them working in our business, and they are incredibly helpful as we become adapting to climate change. I suppose I would say, just a word of caution though, we haven't connected up our own digital twins yet, so that would probably seem like a natural first step. So, you know, if we manage to persuade people to use less water, then that will have a knock-on impact on the sewer system, which we haven't yet modeled. So I think, therefore, you know, there's quite a way to go, I suppose. And if I sort of draw a bit of a parallel, a project that we initiated but did not execute in the end was the National Underground Asset Register, which I felt was incredibly helpful, and we were very lucky. I think the central government stepped in and took that ball out of our hands and got that job done. And I think ultimately, if this is going to have the reach and the impact that it needs, I think it will need something like that.
Brilliant. Thanks so much, Nigel. Jim, please.
Thank you. Good morning, everyone. Jim Hall. I'm not an asset owner, unless that includes a bike, but I am now a commissioner of the National Infrastructure Commission, which in some senses got this ball rolling with the data for the public good report, which has been referred to. And I've also helped to initiate the Daphne platform, which is also very much part of CReDo. Just a few thoughts, if you'll allow me to be a little bit conceptual, in terms of what we understand by digital twins, because we've had many versions of them here, and I think that everything that we're talking about is good. There are more or less broad versions of digital twins, and let's say the purest version relates to real-time interaction between sensors, simulation, and actuation back into the system. And so that's the sort of thing, for example, we see in the canonical example of digital twins, which is jet engines, which are monitored in real time and actually activated as well in response to that monitoring. Here we're talking about a much bigger picture of data and simulation, and I think that's great, and we see a much bigger kind of set of use cases, and in particular use cases in the context where the world is changing very rapidly. And I mean, two instances of that, which I think we need to pay a lot of attention to, is in relation to connected and autonomous vehicles and the way in which they need to be worked out in silico, while they're also getting worked out in practice. I think another thing I would point to is the future of our energy networks, which are getting transformed dramatically with distributed supplies, with demand side response. This is a very different system to interact with intermittent renewable supplies. So very exciting space. National Grid ESO, who are here today, are kicking off work on their virtual energy system, which I'm very excited to be part of. Things we could do better. I mean, the whole infrastructure planning space, which is what we've heard from today in relation to CReDo, in particular, resilient infrastructure planning is one use case. I think digital planning in the sense of how we actually get planning applications done, how people engage with the future of infrastructure and understand what it means in the places that they live in and care about. I think we should be pushing much more on that. There's a whole set of use cases in terms of automation of the construction process, 4D BIM, and so how we drive up productivity in a sector which is disappointing, let's say, with respect to productivity improvements. Environmental monitoring, so how people learn more about the environment which they care about and get engaged in that. For example, we've seen a proliferation of sensor data now coming out in relation to CSO spills, so people actually know what's going on in the rivers near them. And emergency situational awareness, something which CReDo spoke to as well. So there's lots to go at. Great to see CReDo pressing forwards, and I mean, I suppose my final exhortation would be: don't stop experimenting. This is a space which is moving very fast. I don't think there are any definitive solutions, but we've got to keep on trying.
Brilliant, thanks so much, Jim. Tom, can I hand over to you, please, on the call?
Absolutely. Sorry I couldn't be here today. I'm afraid COVID finally caught up with me, so apologies. But yes, so I'm Tom Bogan from Anglian Water. I've been working on the CReDo project from its conception. I've got a history in energy efficiency, so there's maybe a nod towards the energy side of things in here as well. But certainly in terms of my reflections of today, I think this event is showcasing one of CReDo's sort of main thrusts, which is the communication side of things. We're trying to share the information that we're finding and the lessons that we're learning from this process. Tying back, I think, to Nigel's point earlier as well in terms of Anglian Water's digital twin. I think that's a journey that we're on. We're on the roadmap, which is going to span a number of years. But one of the aspects of that is actually achieving interoperability between our various twins, if you will, within Anglian Water. And one of the other great things that's coming from that learning from CReDo is how Anglian Water is able to take some of that learning to try and help us get our different twins to actually talk to each other within the organisation as a stepping stone to then be able to communicate with other twins external to the organisation. But yeah, really pleased to be here if it's only virtually, and back to you.
Brilliant. Thanks so much, Tom. Matt, please.
Hi, Matt Webb. I'm Head of Enterprise Data Management at UK Power Networks, the network and system operator, electricity network and system operator covering the southeast of England. CReDo has been a really important project. The application of it has been well covered. And as has been touched upon, we're at the very beginning of what should be a very long journey. And I see the use cases are potentially endless. I think what's really beneficial beyond the development application of the tool is the learning that we're going through. We talk about digital twins a lot and have done for a long time. For most, they're very conceptual. And finally, we've got something that's really starting to bring it to life and gives you a real world application of what this looks and feels like and the way it can expand and grow. That extensibility that's been spoken about can go off in many directions. We're obviously looking at climate resilience in particular in this instance, and how we, from an asset and infrastructure operator point of view, can inform optimization of investment, planning, understanding of criticality, and really grappling or taking hold of the complexity that is only growing and evolving continuously with the energy systems. As Noel just touched upon, the relationships and those interdependencies themselves are changing. So the greater our ability to really gain actionable insight into that and to respond in the right way now and in the future is only going to be beneficial. But the key point is there's so many aspects to implementing this type of capability that go beyond a nice visual interface, and that's what we're really learning as we progress through this. So it's an exciting project, and we're right at the start.
Brilliant, thanks, Matt. And on the call again, Louise, please. You're on mute, Louise. There you go.
Hello?
We can hear you.
Louise Krug, work in BT's research team. We're looking into how to prevent climate change and how to adapt to climate change. Obviously, climate change, the big impact is sort of increasing extreme weather events that have a direct impact on our fault rates. We do a lot already to try and minimize the impact of faults on customers. There's a lot of, power infrastructure that we have provided to help us recover from electricity failures. But we've also got a huge network. We've got, 5,000 exchange sites, 20,000 mobile masts, 90,000 fiber cabinets. We can't protect everything all of the time, and the better we understand how the systems are interrelated, the better we can protect the services for the customers. If you've got two mobile masts sharing a common substation, today we wouldn't be aware of that common risk to those two sites. So CReDo is given the chance to give us great insights into what's the most sensible way to protect our network. Picking up on a point that was made about the fact that this is currently, aimed at planning and seeing how different events could affect the network. Obviously, it would be great if we could get to full real-time data coming out of the systems. But obviously, if you've got a climate emergency and a lot of your comms are down through some kind of event, you lose all that real-time information. So having the systems actually being able to look at in advance what might be happening, so you can understand what particular set of failures could have been caused by what particular events, because it's no good sending something out to repair a mast that's down when in fact the problem is the electricity supply or something. So understanding how these things interact, even if we don't have that real-time information, can actually help us in real-time situations on the ground. So it's a very exciting project. It's very good the way it's rounded. It's looking not just at the technical aspects, but also looking at the legal, the security implications, these things. Without having tackled those problems head on, this project could have stalled very, very young. So, yeah.
Brilliant. And Nikki, please.
Thank you. Yes, I'm Nikki Van Dyke. I'm a Technical Director for Climate Resilience at Mott MacDonald. As Mott MacDonald has some involvement in phase one, but it's been really fantastic this morning to hear what's happened in phase two and hear how the project's been taken forward. So many things that I could reflect on. We're going to try and pick up a couple of points that maybe fellow panelists haven't mentioned yet. So we, Mott MacDonald, we're not infrastructure owners and operators, but we work with and for lots of UK infrastructure owners and operators. And one thing that we've been quite heavily involved in over the last couple of years is adaptation reporting. So infrastructure owners and operators report to DEFRA on both the risks they face from climate change and their progress in adapting to those risks. And in the last round of reporting, infrastructure owners and operators were asked to explicitly consider interdependencies and interdependent risks. And I think what we saw working with a number of different organisations was that's now starting to happen, but still to a large extent in organisation by organisation. So a water company might start looking at its interdependencies. A transport provider might start looking at its interdependencies, but those conversations are still not happening between organisations to a large extent. So something like CReDo facilitates those kind of conversations. The other bit I was really interested to hear is about the economics and the work that Frontier Economics have been doing. One of the things we hear a lot from the organisations we work with is how do they build and make a business case for investing in resilience. So seeing some of the work that's happened in phase 2 on the economic side is really exciting, and I know will be of direct relevance to many of the organisations that we work with. And finally, the last point that struck me is around how CReDo can be used to look at both resilience and building resilience, adapting to climate change, but the links also to net zero and decarbonisation, and looking at these two sides, if you like, of the climate coin together. A lot of the plans, policies, strategies, actions, interventions that we need to take to reach net zero are themselves going to be affected by physical climate risks, so flooding, high temperatures, etc. So something that like CReDo, where we can start to look at actually how some of this, the actions that we're taking, not just to build resilience, but also get to net zero, how they're affected by each other is really exciting.
Brilliant, thank you all. So we're going to bring up the slider onto the screen now and start asking the questions in order of which they are most liked. So you can still go on and thumbs up and we'll ask those questions. So if we wait for the screen to change in a second. But whilst we're doing that, very happily take any questions from the room here for our panel of experts. So if you have a question verbally, please raise your hand and we will do that as the first question. One at the back here. Put your hand up again so we can see where the mic's going. Brilliant.
Hi, great presentations, by the way. I had one for Nigel. It was just around NUR and the synergies between NUR and CReDo, because NUR is really it's an operational platform which federates infrastructure data. Do you think there is potential for NUR to inform CReDo in the future, given that CReDo's objectives are strategic planning and future investment planning?
I think the short answer to that is yes. I would say, though, I mean, it doesn't. If it's investment planning, then yeah, because it's a relatively static data set, right? So it's being updated, let's say monthly, quarterly by different participants. If you're trying to run an incident, then obviously that's not going to be very useful. If you're looking at long-term asset planning, I think it could be very useful, accepting that not all infrastructure is below ground, and that is really its focus, right? So it doesn't have above ground assets in it, but that would be its limitation. But I think it would be an interesting input, definitely.
Our first question from online is, what external data sources feed flood modelling? For example, Ordnance Survey, Met Office, Environment Agency, and how are they integrated with asset owner data? So would anyone like to take that question?
I can, or Tom, I don't mind if you want to take that. Do you want to take that? No? Okay. So, yeah, I mean, we have there's a very set methodology. It's called the Drainage Water Management Plan, DWMP, 25-year horizon. It takes in a lot of different inputs, including all of the ones that were mentioned there: climate future forecast, population growth, looks at catchment and different approaches. So yeah, that happens, albeit within the context of each individual water company.
Brilliant. Any other comments to add, or?
Much the same for electricity. I think the key thing is in the progression that we're seeing with a tool like CReDo is the granularity and the level of intelligence that's provided. So where you're looking at these macro scale models, your criticality isn't necessarily understanding those more detailed interdependencies. And by understanding and building out that more detailed view, the corresponding two-way interdependencies, rather than just being based on something quite crude like customer numbers, for instance, really starts to inform your understanding of criticality, your level of justification in an investment, both now and in future, as those climate scenarios are changing.
Brilliant, thank you. Our next question from online is, what other sectors, in addition to telecoms, energy and water, are CReDo looking to include? And which ones would be a priority? So if anyone would like to answer that one.
Happy to respond. I think the key message is that there's no preconceived limits. To be honest, the way that CReDo can expand is in a number of ways. Geographical footprint is an obvious one. The cross-section of infrastructure owner-operators that are covered with different climate scenarios. And to be honest, in terms of the foundational elements that underpin CReDo, application of that beyond climate change isn't beyond reason. But certainly, there's certainly no limitations that have been spoken about in terms of who should or should not be participating, and any barriers in that respect.
I might add, I mean, not from a CReDo perspective, but from an asset owner perspective, and an asset owner that experienced Storm Arwen last year, I suppose. So it would seem to me the councils would be an important player here. If you think about what happened in Storm Arwen, lots of trees down, and power off, and obviously hard to produce water without power. So a big impact, but the critical first job was really to remove the trees from the road. And without that, none of us could get safely to our assets to do anything with them.
Nikki, do you want to?
I was going to echo that point, actually, the transportation network. And actually, when we've been working with infrastructure owners, looking at their dependencies, energy, telecoms, and then the third or the big one is transportation, actually being able to get people to and from sites. We did one piece of work, for example, with an airport owner, had amazing, all the great plans, contingency plans, weather resilience, kept the runway open, couldn't get people to or from the airport because of the local transport network was affected. So yeah, transportation would be the one for me.
Something I might just come in on is the interaction between subsurface infrastructure, so sewers in particular, and surface water flooding, which is one of those kind of classic interface problems. It's also an interface in terms of institutional responsibility, because the drainage and the sewers is the responsibility of the water companies. The Environment Agency has responsibilities. Local authorities have responsibilities. And so CReDo, I think, represents possibly an opportunity to join those things up. The National Infrastructure Commission, towards the end of last year, brought out a report on surface water flooding and really pointed to these fragmented responsibilities and a lack of shared understanding and a lack of tools for prioritization, really, in a way which we can look at the surface interventions first, the SUDs, the things which will avoid runoff before looking at sewer solutions. And we argued that we need shared models to come up with very purposeful, time-limited and costed plans to get a grip on the surface water flooding problem.
Quick comments.
I'll be very quick. I just want to re-emphasize the nature of the local authorities and the transport, because we have much better visibility of these storm events than we have done historically. And there's companies like mine, Milestone, which are responsible for cleaning the gullies that help drain highways. So if we know where the infrastructure is likely to be most affected, you can prioritize those areas in the weeks immediately prior to an event. And likewise, it's our people who go out with the chainsaws to remove the trees. So this information really would be very, very helpful for all local authorities in their work prioritization.
Brilliant, thank you. And that leads nicely to our next question from Andrew from the Environment Agency, which says, focus on CReDo appears to be infrastructure resilience, but how can CReDo be used to understand the benefits and impacts on place-based resilience? So any of our speakers, or indeed Tom and Louise, just wave if you want to reply as well. So how can we use CReDo to understand place-based resilience?
And if I might come in a sense, this is all about places. We've been looking at maps and communities and the infrastructure which provides essential services to those communities. I think the trickier part of this question is the proper evaluation of all of the wider benefits of climate risk reduction. We're pretty good at estimating direct damages to assets, looking at potential numbers of people, customers who might be interrupted or impacted by asset damages. But we know that there's a much wider set of social and economic impacts that can be big floods, big spillovers via supply chains, which can ripple right the way across the country. We've seen this in some of the big storms as well, the ways in which infrastructure impacts propagate in very surprising ways. So I'd kind of underline the need for more work, and CReDo is a really good step in that direction to properly evaluate, because understanding those wider economic impacts, the flip side to that is then understanding the wider economic benefits of resilience.
Brilliant. Thank you very much, Jim. Our next question here, we've got a couple of minutes left for questions before we move to our next segment, is around security. So it says, how are you addressing security, assuming CP&I were consulted? Revealing which data has downstream dependent assets sounds like a villain's dream.
Yeah. You can see it on Google Earth. That's all I would say.
Yeah, so to respond to that, security is and has to remain a key focus for all the decision making, and it's about having the right controls and mechanisms and governance processes in place to take those informed decisions. Yes, there will always be an inherent risk when you're transporting, moving, and accessing data, but that shouldn't mean that you don't do that, because then you're not realizing value. You have to get the data to the right people in the right form to make it usable, to get those insights, to make those decisions. Otherwise, we're not going to move forwards. In terms of the approach to this project, there's been a huge amount of time and effort focused on the security controls, the decision making, and ultimately we're in early phases, and we've used data that is either already to a large extent in the public domain or isn't highly sensitive in its own right. And more importantly, the use of synthetic data was touched upon during demonstrators and so on. So we've really removed that inherent risk. But absolutely, as this moves forward, words right, and scales, that's where clearly we're going to need to have even more robust tools and decisions in place. The legal agreements and licenses that sit around this, the control mechanisms, the technologies, and those with expertise in cybersecurity and so on, looking at this, designing the security in from the word go, exactly as Jethro was describing earlier, make sure that we don't fall foul of any issues. But it should not be a significant barrier to progression. If we always focus on the risks of releasing data, we'll never release anything.
Brilliant, thanks. And Louise, going to you on the call, please. And then Tom.
I guess there's also the thing about being canny about what data we do need to release to make this work. And this is where the whole concept of distributing the twins sort of starts to come into its own, because we don't necessarily need to share a lot of infrastructure information. We need to share the information about what assets might have been impacted. In a simple terms, for example, I don't need to tell you what ducts or telephone poles you're using, what exchanges you go through. I simply need to tell you that your phone number is going to be affected. So that there can be ways of sharing the required information without having to give everybody full visibility of every piece of infrastructure and have it all stored on some common place that is easy to be attacked. So that's why this project is sort of iteratively working through how we design and build the models and stuff, so that we can start to minimize the amount of information that really needs to be shared.
Brilliant, thanks, Louise. And final comment from Tom, and then we'll bring this panel to a close. Tom.
Yes, thank you. It's mainly just to build on what Matt and Louise have already said, but yeah, we absolutely did consult the CP&I on this particular project. The choice of where we are actually putting the data has been heavily informed by their advice. But yes, the idea of data in aggregate having a greater value and therefore greater risk is absolutely central to the CReDo principles here. And as Louise was just saying, the idea of actually being able to disaggregate to be able to have those protections and only share what is absolutely necessary is part of the learnings that are coming from this project. Done in the very secure way that we have done, and it has been, it's felt almost too secure sometimes. We did talk about those padlocks on phase one compromising some of the outputs we would have liked to have gained from phase two, but that is at that level of interest we have in the cybersecurity that we would actually tread very carefully in this area. But yeah, nothing more to add than that. Thank you.
Brilliant, thank you, Tom. So that's all we have time for this segment. So I'd like to thank our panelists, please. May take your seats, panelists. Thank you. So the questions we didn't have time to answer in that segment, we will be answering in another mechanism, either online or otherwise. But whilst the chairs get cleared, I'm just going to introduce Chris from Connected Places Catapult, who will be saying a few words next. Chris, please.
Hello, everyone. I'm Chris Jones. I'm the Ecosystem Director for Integrated Infrastructure here at the Catapult. My role is to work with the market in the broader sense to identify and help to solve some of the most critical challenges that are facing the cross-infrastructure sectors. I thought it worth joining the dots before we go into the next question session. For those of you who might not be so familiar with the Catapult network, in why we're interested in projects like CReDo. There are 9 catapults across the UK, across 40 locations, and each of us has a sectoral focus. And our role is really accelerating business growth and stimulating the market. So at Connected Places Catapult, we do that with a focus on cities, transport, and place leadership. We're driven by our innovation imperatives, connected intelligence, climate action, and people's experience. And really what we aim to do is bridge that gap between research and industrial application. And together, the catapults help to tackle some of the biggest challenges facing society and industry. One such challenge we've heard much about this morning is climate resilience and adaptation with respect to better understanding cross-infrastructure dependencies. I think CReDo really is a great example of that catapult ethos in bringing together infrastructure sectors, generating conversation, identifying common ground, and really sparking innovation. So I mentioned that I lead our integrated infrastructure ecosystem. CReDo is a project in my portfolio, but really it's much more than that. It's a key component of our strategy. The ecosystem itself is a really exciting one, and it's driven by systems level thinking to connect, shape and grow infrastructure sector activities across energy, water, roads, telecoms, and broader cyber physical infrastructure, much more. So if, like me, you believe that connected, robust, and resilient infrastructure provides the foundation of a productive and economically strong place, then I'm sure you'll agree, based on what we've heard today and seen demonstrated, that CReDo is strongly contributing to that agenda. So that brings me swiftly on to plans for CReDo in the coming year. So at the Catapult, we use our core funding from Innovate UK to address barriers that inhibit collaboration across different sectors. And CReDo is one project that we've been investing in during the current year, and we'll continue to invest in 23 and 24. We'll continue to host and maintain the platform through 23-24. And additionally, to pick up some of the points that our other speakers raised earlier, we'll be investing to assess the learnings to date and really deliver a business case for cross-sector collaborative approaches to data sharing across infrastructure sectors. And we do that with a goal to improve decision-making, to support asset owners to make an investment case for connected digital twins in their own business. And the specific approaches we'll take are really in the bubbles on the slide. So engaging with sectors, stakeholders to support market intelligence and opportunity analysis around the resilience use case. And this is really that impact assessment and stakeholder engagement. And secondly, we'll be developing the business case for a coordinated approach to infrastructure resilience through different stakeholder lenses. And we hope that can be used within the infrastructure sector to build confidence and understanding of opportunities to invest in your own assets or in the assets of those on which your assets depend, to improve resilience of self and of system more generally.
Thirdly, we'll be convening regulators, public and private bodies to demonstrate value and impact assessment. So as we get towards the autumn, we hope to gather again, perhaps as we're doing now today, or a similar online event, to talk with you, our stakeholders, and to gain soundings on the gaps and feed that back into our business case development. And then fourthly and importantly, we've got ambitious collaborative research and development plans to scale CReDo. So we've made what I describe as a good start. We're out in the market, we're looking to win from some of the regulator innovation funds, further funding to scale the solution, with the goal of delivering unique value to those sectors such as energy and water that we're working with spillover benefits to other CReDo users, but really we need to do more together. So I guess that ends on this slide. What can we do together and how can you help? So we want you together with ourselves to take action. And this slide was up earlier with one of the other speakers, but it's good to end on it from my perspective. So the CReDo team would love to hear from the audience in the broader sense. So whether you're an infrastructure owner, an operator, a regulator, policymaker, a researcher, a funder, investor, or any other thing you care to label yourself as, we want to hear from you. And the way to do that is via the Take an Action pages on the CReDo, for CReDo on the Digital Twin Hub website. I believe a colleague may be putting the link in the chat for those of you online, so I hope that's happening in parallel. If it isn't, we'll make sure you get it later. But otherwise, we look forward to working with you as CReDo enters its third phase. Thank you.
Brilliant. So thank you, Chris. We're going to bring the team up from CReDo to ask a couple of final questions, which will keep quite tight and time bound to the ones that are the most liked on the list that are relevant to the team. And then we will bring the webinar for those online to a close. And those of you joining us in the room, we have the networking event just afterwards. So any burning questions, do save them for that. But also we will be answering all the questions that have been captured on Slido outside of this session. So your questions haven't been lost. Right, so welcome to the team. The slide behind will change in a second to show who they are. And we will go through and ask the questions in order of which they're most liked. So first question, does CReDo work on historic data or does it integrate any IoT sensors data that comes in real time?
In CReDo phase 1, we demonstrated the possibility of pulling in sensor data from the Environment Agency. It's still demonstrated on the CReDo 1 demonstrator published on the Digital Twin Hub. So yes, it is capable of pulling in sensor data. It wasn't something that we've done CReDo phase 2 because it wasn't necessary for the immediate use case. And I've forgotten the second part of the question.
Just IoT in real time or right time data, maybe more appropriate.
Answered.
Super. Thank you.
I think there was a bit on historic data
yes.
as well. So I can answer that. We haven't actively used any historic data. We've been much more focused on like future risks that we expect to be more impactful. But going forwards, there are plans to use that historic data. And, you know, there's a lot of things you can do by having both sides of the scenario. It opens the opportunities for things like AI and machine learning based on knowing what happened, what the inputs were to what happened, and then what actually happened. And if we can model that and we can test our system with it.
Great, thank you. Our next question is, what software models and platforms were used to build CReDo? Is it open source and can it easily be replicated or adopted by other organizations?
It is all open source. There was a detailed report published at the end of phase 1 that talked about almost all of the software that is currently being used in phase 2. There'll be another report issued at the end of phase 2 that provides a brief update. The details of where to find the software from phase 1 are available in that report. The same will be true of the phase 2 report once it's published.
Brilliant. And that report you can get from the Digital Twin Hub. So please check it out. Plug. Great. Our next question here is, will CReDo be able to provide a blueprint to support data sharing agreements?
Yeah, I'll take that one. We hope so. We recognise that this is a demonstrator. We're trialing new ways of doing it, but we think that the approach that we've taken to sharing data between asset owners is pretty novel, and it's difficult to do, and that's where the Catapult comes in. We do have templates of data sharing agreements also hosted on the Digital Twin Hub that people can access and look at. But we're also doing some future work as part of the Digital Twin Hub with some working groups with the community to look at what's the best way to build these data licenses to share between different asset owners. And we hope that that wider piece of work will be useful for CReDo and for other digital twins that want to connect up to each other in the future.
Brilliant. And Sarah?
Yeah, just to add to that, so CReDo, we have a data sharing agreement in CReDo, but we've always been very conscious of what other initiatives are doing. So with NUAR as well, other data sharing initiatives, virtual energy system. So I think we're always keen to sort of put ours out there as much as we can, but also to compare it to other data sharing agreements, because I think it's an evolving process, isn't it? And it's important that different data sharing initiatives are sharing our approaches. So we can ultimately, it's not to say CReDo has the right approach, but perhaps it does in this particular use case. And can we look at what NUAR are doing, and then we'll start to sort of figure out, okay, what is best practice across sectors, across industry? That's the direction that we want to head in.
Collaborate on the rules, compete on the game.
That's it.
That's it. Excellent. Next question is, what would be the best way to expand CReDo to include transport or any other sectors?
Yeah, I mean, this is a huge question. I think transport is obviously a really interesting one. I think something that directly relates to the flooding scenario is something that we've already covered throughout the panels and other talks. So, when it's about the operations of responding to the flooding event and how you can get engineers or people to the right locations. And a lot of that is directly related to transport. But then more widely, there's the feedback effect of the loss of services to the broader transport network, like rail or other things.
Brilliant. Thank you. One of our penultimate questions here, are regulators engaged and engaging? And what are project implications? So I'm reading this wrong. What are project implications for the regulated utility markets, infrastructure investment, and undersupply of public goods? So are regulators involved and engaged? And what are the project implications?
Yes, they are. So we have regulators who've joined us today as part of this session, and we're very keen to continue that conversation with the regulators. I think there are two angles to this. One is around looking at how you promote cross-sector innovation, because of course, when there are public benefits, public good effects, it's the question of who funds it and how do you incentivize and stimulate that cross-sector innovation. The other angle is cross-sector resilience, and how do we measure cross-sector resilience? And again, how do we put the right metrics in place, and how do we incentivize it when the regulators will typically look at individual sectors? So how do we move from sector resilience to system resilience? And that's a conversation that we want to continue with the regulators. And I think that's, it's a case of bringing government departments together, regulators, asset owners, everyone needs to be a part of that evolving conversation.
Brilliant, thank you. And our final question before we come to a close is, if a firm had their own digital twin, could this plug into the CReDo network? How can others get involved?
Maybe Chris?
We can certainly explore whether it could plug in. I suspect it's going to be more complex than just plugging it in and playing, but it's something that we're absolutely keen to explore with you. And if you do have a digital twin, you're keen to connect with our solution here, absolutely get in touch with me or colleagues afterwards. On the technical side, does anyone want to comment how we would achieve that?
Well, I think, firstly, just to remind everyone, there is a call to action. It was mentioned at the end of the CReDo video. It's reproduced on the digital twin on the DT Hub. From a technical point of view, CReDo is designed to be extensible. The idea of the computational agents is such that it should be possible for a piece of software to be written and incorporated in CReDo. The question, of course, coming back from that would be, What would the software seek to do? Would it benefit from that data? And would it add value to the CReDo or the wider use case? And I think it's always important to think about what you're doing and trying to achieve by considering the use case or the use cases and what they need in order to deliver success.
Brilliant, thank you. So thank you for our panelists.
Hi, everybody. I'm Yelena Coleman. I'm the Director for Applied Data and Technology here at the Connected Places Catapult. It's been absolutely fantastic to see the journey of CReDo over the last 2 years, and I hope today has given you some insights into where we are at the moment. So as mentioned a few times before, we'd love to hear from you if you'd like to be involved with CReDo going forward. That could be as a regulator, policymaker, asset owner, or other. Please do come and chat to us after the event, or you can send us a comment on the DT Hub webpage, as we'll share the link and has been shared by Chris and others. So to close the session today, I would just like to say some thank yous. First and foremost, to the absolutely incredible team that has been working on CReDo. We've got a big team with multiple partners, and the way that they've all worked together has really, really been inspiring. So thank you, and a big thanks, I don't know where it is now, Jethro, for sharing an insight into the technical side of CReDo as well, which I think is really interesting. A big thank you to Simon Evans, who's been our host for the event this morning, and a big thank you to our events team who have smoothly run a hybrid event, which is not always easy to pull off. So thank you very much to them. A big thank you to our panelists. So coming, sharing your insights, your opinions, your updates on what you're all doing around climate resilience. And a big, big thank you to the asset owners. So BT and Openreach, UK Power Networks, and Anglian Water. You've been such enthusiastic participants in this project, and honestly, this would not be where it is today without your participation. So thank you for that. And lastly, to our audience, to everybody here in person today and everybody online, thank you so much for coming to join us. For the people who are here, we will be having networking and lunch outside until 1:30. So hope to catch up with some of you there. Thank you very much.
So that brings our conference to a close. The session was recorded, the questions are all online. So if you do have any questions still, please continue to ask them. We will try and answer all of those in the best way possible. And as always, DT Hub, Digital Twin Hub, that's where the conversation's at. So please head there. Thank you everyone for joining us online today. Greatly appreciated sitting through these 2 hours. I think there's 300 plus of you online, so thank you very much. And for those in the room, thank you again. Networking drinks and dinner, or lunch even, not dinner. Wow, how long has this conference been? Next door. Thank you very much.